To determine the appropriate feeder size for subpanels, several factors need consideration, primarily the total amperage of loads connected to the subpanels and acceptable voltage drop. The maximum allowable voltage drop is 5%. Without knowing the total amperage draw of the connected loads, we cannot determine the exact feeder size required. However, we can provide general guidelines based on typical loads. Firstly, for a 90 amp feeder, it is suitable for subpanels with a total amperage draw of up to 72 amps, which is 80% of the feeder capacity. Secondly, for a 100 amp feeder, it is suitable for subpanels with a total amperage draw of up to 80 amps, which again is 80% of the feeder capacity. Thirdly, for a 125 amp feeder, it is suitable for subpanels with a total amperage draw of up to 100 amps, also 80% of the feeder capacity. For outdoor installations, either aluminum or copper conductors can be used. Aluminum is less expensive than copper, but it is more susceptible to oxidation and requires larger conductor sizes for the same ampacity. Copper is more expensive than aluminum, but it is more resistant to oxidation and requires smaller conductor sizes for the same ampacity. Here are the recommended wire sizes for different ampacities and conductor materials using X/3 with ground Romex. For a 90 amp circuit, use 3 American wire gauge copper wire, or 1/0 American wire gauge aluminum wire. For a 100 amp circuit, use 2 American wire gauge copper wire, or 2/0 American wire gauge aluminum wire. For a 125 amp circuit, use 1 American wire gauge copper wire, or 3/0 American wire gauge aluminum wire. Based on these general guidelines, and without knowing the specific amperage draw of the loads connected to the subpanels for panel number 1, which has a 35-foot run, a 100 amp feeder using number 2 American wire gauge copper conductors is recommended for less voltage drop compared to aluminum. For panel number 2, which has a 70-foot run, a 125 amp feeder using number 1 American wire gauge copper conductors is recommended to minimize voltage drop over the longer distance. Note that these recommendations should be verified by a qualified electrician to ensure that the appropriate feeder size and conductor materials are used for the specific application and electrical code requirements. It's crucial to accurately calculate the load on each subpanel. This involves adding up the amperage of all devices and appliances that will be connected to the subpanel simultaneously. Factor in any potential future expansion or additions to the load. Once the total amperage draw is determined, select a feeder size that can handle at least 125% of the load. This provides a safety margin and prevents overloading the circuit. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause appliances to malfunction, lights to dim, and motors to overheat. The longer the wire run, the greater the voltage drop. The smaller the wire gauge, the greater the voltage drop. To minimize voltage drop, use larger wire gauges for longer runs. Consult voltage drop charts or online calculators to determine the appropriate wire size. Aluminum conductors are less conductive than copper conductors, so they require larger wire gauges for the same ampacity. However, aluminum conductors are also less expensive than copper conductors. Consider using aluminum conductors for longer runs where voltage drop is a major concern. Check local electrical codes for any restrictions on the use of aluminum conductors. Romex cable is a type of non-metallic sheath cable that is commonly used for residential wiring. Romex cable is relatively easy to install and is available in a variety of wire gauges and conductor configurations. When using Romex cable for subpanel feeders, ensure that the cable is rated for the amperage of the feeder. Also, make sure that the cable is properly supported and protected from physical damage. Grounding is an essential safety measure in electrical wiring. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker and prevents electrical shock. When installing subpanel feeders, make sure that the ground wire is properly connected to the main panel and the subpanel. Also, ensure that the subpanel enclosure is properly grounded. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When installing subpanel feeders, make sure that the feeder is protected by an overcurrent protection device that is rated for the amperage of the feeder. The overcurrent protection device should be located at the main panel. The National Electrical Code, or NEC, is a set of standards for electrical wiring that is adopted by most jurisdictions in the United States. The NEC provides detailed requirements for the installation of subpanel feeders, including wire sizes, conductor types, grounding, and overcurrent protection. When installing subpanel feeders, it's essential to comply with all applicable requirements of the NEC. Permits and inspections are required for most electrical work, including the installation of subpanel feeders. Contact the local building department to obtain the necessary permits and schedule inspections. Inspections ensure that the electrical work is performed safely and in accordance with electrical codes. A qualified electrician is a professional who is trained and licensed to perform electrical work. If you're not comfortable working with electricity, it's best to hire a qualified electrician to install the subpanel feeders. A qualified electrician can ensure that the work is done safely and correctly. The type of loads connected to the subpanels significantly influences the required feeder size. Lighting circuits typically draw less current than appliance circuits. Electric heaters, air conditioners, and power tools can draw significant amounts of current. Estimate the amperage draw of each load and factor in any potential future additions. The distance between the main panel and the subpanel affects voltage drop. Longer distances result in greater voltage drop. To minimize voltage drop over long distances, use larger wire gauges. Alternatively, consider using a higher voltage for the feeder, such as 240 volts instead of 120 volts. A higher voltage reduces the current flow and minimizes voltage drop. The ambient temperature can affect the ampacity of conductors. High temperatures reduce the ampacity of conductors. If the subpanel feeders are located in a hot environment, such as an attic or garage, aerate the ampacity of the conductors accordingly. Consult ampacity correction factors in the NEC. The method of installation can affect the ampacity of conductors. Conductors that are installed in conduit or cable trays have a lower ampacity than conductors that are installed in free air. This is because conductors in conduit or cable trays are not able to dissipate heat as effectively. Consult ampacity tables in the NEC for different installation methods. The type of insulation on the conductors can affect their ampacity. Conductors with higher temperature ratings have a higher ampacity. Use conductors with the appropriate temperature rating for the application. Common insulation types include GHHN, THWN, and XHHW. The number of current-carrying conductors in a raceway or cable can affect their ampacity. When multiple current-carrying conductors are installed in the same raceway or cable, their ampacity must be derated. This is because the heat generated by the conductors can raise the temperature of the raceway or cable. Consult derating factors in the NEC. The voltage rating of the conductors must be equal to or greater than the voltage of the circuit. Using conductors with a lower voltage rating can be dangerous. Common voltage ratings for conductors include 300 volts, 600 volts, and 1000 volts. The wire gauge is a measure of the diameter of the conductor. The smaller the wire gauge number, the larger the diameter of the conductor. Larger conductors have a lower resistance and can carry more current. Wire gauges are typically expressed in American wire gauge, or AUG. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor depends on its size, material, insulation type, and installation method. Ampacity tables in the NEC provide the ampacity of conductors for various conditions. The voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Voltage drop is caused by the resistance of the conductor. The longer the wire run and the smaller the wire gauge, the greater the voltage drop. Voltage drop can cause appliances to malfunction and lights to dim. The impedance is the total opposition to current flow in an AC circuit. Impedance includes resistance, inductive reactance, and capacitive reactance. Impedance can affect the voltage drop and current flow in a circuit. The short circuit current is the maximum amount of current that can flow in a circuit during a short circuit. The short circuit current depends on the voltage of the circuit and the impedance of the circuit. Overcurrent protection devices must be able to interrupt the short circuit current. The ground fault current is the amount of current that flows to ground during a ground fault. Ground faults can be caused by insulation failure or accidental contact with a grounded object. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock by interrupting the circuit when a ground fault is detected. A surge is a transient overvoltage in an electrical circuit. Surges can be caused by lightning strikes, power outages, or the switching of electrical equipment. Surge protective devices, or SPDs, are designed to protect electrical equipment from damage caused by surges. Harmonics are unwanted frequencies in an electrical circuit that are multiples of the fundamental frequency. Harmonics can be caused by nonlinear loads, such as electronic devices and fluorescent lights. Harmonics can cause equipment to overheat and malfunction. Power factor is a measure of how effectively electrical power is being used. A low power factor can cause increased energy consumption and reduced equipment efficiency. Power factor correction can improve the power factor and reduce energy costs. Electrical codes are a set of standards for electrical wiring that are adopted by most jurisdictions. Electrical codes are designed to protect people and property from electrical hazards. Electrical codes cover a wide range of topics, including wire sizes, conductor types, grounding, overcurrent protection, and installation methods. Electrical inspections are performed by qualified inspectors to ensure that electrical work is performed safely and in accordance with electrical codes. Electrical inspections are typically required for new construction, renovations, and repairs. An electrical permit is a document that authorizes electrical work to be performed. Electrical permits are typically required for new construction, renovations, and repairs. Contact the local building department to obtain the necessary permits. A qualified electrician is a professional who is trained and licensed to perform electrical work. A qualified electrician can ensure that electrical work is performed safely and in accordance with electrical codes. It is always best to consult with a qualified electrician before undertaking any electrical work. Ensure that the subpanel is properly labeled with its voltage, amperage, and the circuit it serves. This makes it easier to identify and troubleshoot problems in the future. Create a circuit directory for each subpanel that lists the loads connected to each circuit breaker. This helps in quickly identifying the correct breaker to turn off when working on a specific circuit. Regularly inspect the subpanels for any signs of damage, such as corrosion, loose connections, or cracked insulation. Address any issues promptly to prevent potential hazards. Periodically test the circuit breakers to ensure they are functioning properly. This can be done using a circuit breaker tester or by manually tripping the breakers. Make sure all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires. Use a torque wrench to tighten connections to the manufacturer's specified torque. Do not overload the subpanels. Overloading can cause the circuit breakers to trip and can damage the wiring. Balance the load between the two legs of the subpanel to prevent uneven loading. Uneven loading can cause voltage imbalances and can reduce the efficiency of electrical equipment. Keep the subpanels clean and free of dust and debris. Dust and debris can accumulate on electrical components and can cause them to overheat. Use a vacuum cleaner to clean the subpanels periodically. Ensure that there is adequate ventilation around the subpanels. Overheating can damage electrical components and can reduce their lifespan. Do not block the ventilation openings in the subpanel enclosure. Install surge protectors to protect the subpanels from voltage surges. Voltage surges can damage sensitive electronic equipment. Consider using arc fault circuit interrupters, RFCIs, to protect the subpanels from arc faults. Arc faults are a common cause of electrical fires. Make sure that all wiring is properly supported and secured. Loose wiring can be a safety hazard. Use cable ties or clamps to secure the wiring to the subpanel enclosure. When working on electrical equipment, always turn off the power at the main panel. Use a voltage tester to verify that the power is off before touching any electrical components. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Never work on electrical equipment when you are wet or standing in water. Be aware of the potential hazards of working with electricity. Electricity can be dangerous if not handled properly. If you are not comfortable working with electricity, hire a qualified electrician. Understand the local electrical codes and regulations. Electrical codes vary from jurisdiction to jurisdiction. It is important to comply with all applicable codes. Follow the manufacturer's instructions for all electrical equipment. The manufacturer's instructions provide important information about the safe and proper use of the equipment. If you have any questions about electrical safety, contact a qualified electrician or your local building department. Remember, safety should always be your top priority when working with electricity. When selecting a subpanel, consider its physical size and the available space for installation. Ensure that the subpanel can be easily accessed for maintenance and repairs. Choose a subpanel with an adequate number of circuit breaker slots to accommodate current and future needs. Consider using a subpanel with a main breaker to provide additional protection and convenience. Use properly sized conduit to protect the feeder wires from physical damage. Ensure that the conduit is securely fastened to the subpanel and the main panel. Use appropriate fittings and connectors to ensure a tight and watertight seal. Avoid running the feeder wires through areas where they may be exposed to moisture or extreme temperatures. If necessary, use weatherproof enclosures or insulation to protect the wires. When installing the subpanel, ensure that it is level and plumb. Use shims to adjust the position of the subpanel if necessary. Secure the subpanel to the wall or other mounting surface using appropriate fasteners. Follow the manufacturer's instructions for grounding the subpanel. Proper grounding is essential for safety. Use a ground bus bar to connect all ground wires within the subpanel. Use a separate neutral bus bar for all neutral wires. Do not connect ground and neutral wires together on the same bus bar. When connecting the feeder wires to the subpanel, ensure that the connections are tight and secure. Use a torque wrench to tighten the connections to the manufacturer's specified torque. Double check all wiring connections before energizing the subpanel. Ensure that all circuit breakers are in the OFF position before turning on the main breaker. Use a voltage tester to verify that the voltage at the subpanel is correct. Test each circuit breaker by turning it on an OFF. Verify that the circuit breaker is supplying power to the intended load. Label each circuit breaker with its corresponding load. Create a circuit directory that lists the loads connected to each circuit breaker. Keep the subpanel clean and free of dust and debris. Regularly inspect the subpanel for any signs of damage or wear. Address any issues promptly to prevent potential hazards. If you are not comfortable working with electricity, hire a qualified electrician to install or maintain the subpanel. Always prioritize safety when working with electricity. By following these guidelines, you can ensure that your subpanel is installed and maintained safely and effectively. In conclusion, selecting the correct feeder size and conductor material for subpanels involves careful consideration of load calculations, voltage drop, and code requirements. Consulting with a qualified electrician is highly recommended to ensure a safe and compliant installation.